So I welcome Andrea to kick off the session with a presentation of the MATS multi-method approach with system dynamics. Andrea, the floor is yours.
Thank you. Thanks, Mari. So going into the content now, as opposed to facilitating, as I've done in the very first part of the meeting. And I'll start by sharing some information on the MATS project and the modeling framework that we have used in the project. So to get started with, we had to use an integrated approach. And that is primarily because, as you have heard earlier, we have 15 different case studies that cut across a variety of different geographical areas and focus on different types of commodities. So we decided to look at three main dynamics within these systems. One is the trade dynamics, taking more of an international perspective and more economic. Then we looked at production, which is more of a national dynamic, meaning we look at what is happening at the country level in terms of productivity, effectiveness of production, and so on and so forth. And this has to do with both economic, environmental, and social indicators. And so we have to expand the comprehensiveness of the analysis. Then we look at production outcomes, meaning that we need to consider at the local level, not only national level, so this could be potentially landscape, community level, what are, again, the economic, social, and environmental impacts of production. Now, these social, economic, and environmental indicators may not be exactly the same when we look at national performance as opposed to local performance, because some of, for instance, the ecosystem services are more meaningful when measured at the local level than at national level, say, for instance, water-related dynamics. But nevertheless, we want to make sure that we have that comprehensive framework that allows us to tackle all these different possible changes emerging at the local, national, and international level. So as the next step, having identified what are the key areas that we want to analyze, we started looking at indicators. So what are the social, human, economy, markets, natural capital, policy, and governance and related regulations indicators that we could analyze, both with qualitative and quantitative modeling. And at the same time, what is the connection to the SDGs? So we wanted to make sure that whatever indicator we use is explicitly connected to the SDGs. Now, with that information, we then started identifying what are the methods and models that we should use. So we have not started with a set of models as a starting point. We started with indicators, and then we tried to figure out what are the best methods and models that help us providing useful information for policymaking in relation to these dynamics and changes that happen at the local level. So we have then employed a variety of methods and models. On a qualitative level, we use causal loop diagrams or system maps. For trade dynamics, we employed a computable general equilibrium model with global scope. But then when we look at the production dynamics, we use integrated models, system dynamics models that allow us to see what is the repercussion of production practices on social and environmental dynamics. But then at the local level, we also use spatial models to be able to better understand and quantify impacts on ecosystem services, especially in situations where land cover will change. Now, the parameterization of the models, the customization of the models, the setup of scenarios have been informed by the case studies. And so we have the CG model that is applied at the global level, of course, with emphasis on the Europe and Africa dynamics, trade dynamics, but then the other case studies or the other models that we have developed are case study specific. And so that we were able to learn from a top-down analysis, CG model, and a bottom-up analysis, a series of case study related models, what are the implications of using different practices and implementing different agriculture-related policies that have to do with trade. Now, this has provided inputs to the other work packages of the project. And modeling, as you see at the center, is work package 3. And so this has informed the work on work package 4, institutional, regulatory, and legal frameworks, and then on the transition pathway. That is the main aim of work package 5. Now, all these work together will inform the contribution that MATS provides to policymaking. And so the goal here is to develop and pilot these new tools for a systemic analysis that really highlights the interaction between agricultural, trade, investments, and sustainable development. So again, similar but complementary to what Martin has mentioned earlier for Trade for SD, with a heavier focus on agriculture and on the case studies. Now, why do we need to take an integrated modeling approach and use different methods and models? Here you see the case studies and the coverage of the case studies. At the top left corner, we see that we cover Africa, of course, Europe. There are elements or case studies that target South America and Asia. And then also, we look at different types of commodities that are being covered: beef, coffee, dairy products. There are multiple commodities in certain case studies. And at the same time, there is a different coverage of SDGs. Nevertheless, there are many SDGs that are considered in the case studies that we have analyzed. So there is no single model that allows us to basically cover all these different contextual differences across the different case studies. And if we zoom into the SDGs, we see that, of course, there are some common elements. Like we focus a lot on the poverty aspect, we focus on the nutrition, the zero hunger SDG 2 aspect, but then there are many other factors that emerge in different ways in different case studies. So once again, even the models that we have developed for the different case studies are different. In some cases, we use spatial analysis, in other cases, we don't. In some cases, we focus on ecosystem services, in others, we focus on cost-benefit analysis. If the primary issue is different in the different case studies. In one case, the issue may be related to water quality. In the other case, it may be related to the economic viability of investments for sustainable production at the country level, as opposed to what is happening in trade-related markets, in markets that provide import and export opportunities. And so overall, if you look at this image, you will see how we have managed to combine these different modeling approaches. On the top right corner, we see the CG model, and this is where we are able to estimate regional trade dynamics in terms of production and value, as well as national trade dynamics. But then these analyses with the CG model is being informed by the work that we have carried out at the case study level. And in that specific case, we look at more of the socioeconomic indicators. We measure them in physical units. So we look at hectares of land, ton per hectare per year of productivity, number of jobs created, and then we convert these into economic values. One is the value of production. The other one would be the income generated from the employment that emerges from the intervention options that we have analyzed. But we also perform an economic valuation of the ecosystem services, which we find on the left side of this diagram, estimated with spatially explicit data. So that would be carbon storage, habitat quality, nutrient cycling, for instance, and avoided soil loss with sustainable practices, and so on and so forth. Now, these parameters that we obtained from the case studies have been used to support the formulation of scenarios in the CG model, so that we were able to include specific indicators added to the production function in the CG model that would allow us to see what happens if sustainability criteria were considered in the analysis. And so if we were to summarize it, looking a bit deeper at the different types of case studies that we have analyzed, we have socioeconomic models, we have spatially explicit models to capture changes on the environmental side and ecosystem services, and then we have qualitative system mapping. So what we've done is that we looked at a series of specific case studies that we have used as pilots. For instance, we look at poultry production in Ghana, dairy production in Finland, pork production and feed primarily production in Brazil, and a global assessment on milk production. For these case studies, these pilot case studies, as you can see, we have carried out a qualitative analysis first. That is to understand what are the key indicators to track and quantify, and what are the interconnections across these key indicators. And then for Ghana, we carried out an economic analysis, that is a cost-benefit analysis, both financial and economic, so to look at the societal value of production. For dairy production in Finland and pork production in Brazil, we added spatially explicit models. And then for the global assessment of milk production for case study 13, we did a socioeconomic analysis, but in this case, not only cost-benefit analysis, we fully developed a systems model to make sure that we can see dynamics at play for global production. Then other case studies have used different methods and approaches, meaning that we wanted to pilot test this integrated modeling framework in a few case studies, but then the information has been provided to others and different methods and models have been used in these other cases. Then, as indicated earlier, the CG model was developed and applied to make so that we can take into account the economic and trade data that are not captured for the most part in the specific case studies that we have analyzed. But at the same time, they include a greenhouse gas inventory, they include potential changes in land productivity resulting from the use of more sustainable practices. And so we made so to align the CG analysis to the main findings that emerge from the integrated assessments that we have carried out for the different case studies. Now, on to show some of the examples of the work we have done and to highlight the integrated nature of this work. What you see here is a causal loop diagram, and this is created for the Finnish dairy production sector. I don't want to present it in detail. I just want to highlight that there are different thematic areas embedded in this model, and that several of the key variables that are relevant to the sectors are listed in this diagram, and they're also interconnected with one another. So at the center, for instance, we see the number of animals that determines the amount of feed that is required and the amount of land that is needed to produce the feed that is needed. Now, that may lead to shortages of suitable land. And that makes so that there is a constraint to the number of animals that can be embedded in the system or that are part of this production sector. Now, there are consequences of that, consequences for employment, for instance, consequences for revenues. And we want to make sure that all these different elements are interconnected to make sure that, once again, we can identify what are the potential bottlenecks, in this case, availability of suitable land, but also potentially greenhouse gas emissions, degeneration of manure, and the concentration of manure on land, to make so that we can figure out ways to have more sustained and sustainable growth where it is required, or whether we can actually reduce production numbers and producing in a more sustainable way, increase the value addition of the sector. So in this case, we see same diagram, but an overlay of the main thematic areas that are covered in these assessments. Again, at the center, we have animals, land, manure, and emissions. But then on the right side, we couple these analyses with economics, with revenues, cost of production, and the subsidies, so the support that's being provided by the government, to then link to demand, which is consumer preferences, which is changing towards more sustainable production, to make so that at the top, we can figure out what is the ultimate impact on the income of farmers and therefore regional economic activity. Now, as I said earlier, different approaches have been used for different case studies, but we wanted to cover all the key aspects at the same time. So here you see an example of a cost-benefit analysis developed for poultry production in Ghana. Now, in this case, of course, we developed a system diagram like the one you've seen earlier, where the economic dynamics emerge, economic thematic areas emerge. And so here you see that in an Excel file, we have built in the capital cost of the intervention option that would happen early in time. And this is for the year 2023. And then we're able to capture what are the consequences of that investment in terms of cost for operation and maintenance, and then what are the added benefits towards the bottom of the table for manure production, meat production, and potentially subsidies that are provided or required to produce in a sustainable way. Now, different files for this model have been created to make sure that we capture different ways of producing, to make sure that we can reduce some of the operational maintenance costs, we can reduce the cost of the generation of different externalities, to get to, at the bottom of the sheet, the internal rate of return, a benefit to cost ratio, net present value, and the payback period. So this is, again, to provide information on the economic viability of investments that are resulting in more sustainable dynamics, sustainable outcomes, and possibly, if these are economically viable, also strengthen trade dynamics across countries. Now, one more causal diagram to show you how different they are when it comes to different types of investments and contexts. In this case, we're looking at case study 15, and we are targeting specifically olive oil production. Now, in this case, the focus is really on the land productivity, in addition to the land availability, and the water demand. Water availability and irrigation efficiency are two critical factors to consider, with water availability being a constraining factor and irrigation efficiency being one of those intervention options that can unlock more production and actually make it more sustainable. But again, each of these diagrams covers the social, economic, and environmental dynamics. And in some cases, where the environmental dynamics are very important, such as in the case of case study 14 for the production of soybean in relation to pork production in Brazil, we moved ahead, and on the quantitative side, we started looking at land cover change to make sure that we can estimate different types of ecosystem services and how they change over time. So here you find different maps. On the left side, you just see the geographical area. At the center, you see the land cover of the area. And then on the right side, we see carbon at the top, carbon sequestration, habitat quality at the center. And then at the bottom, we have runoff, water retention, basically. And so this is just an example of 3 ecosystem services that we have analyzed that were then quantified for the whole region under different scenarios of land use, intensive, extensive, and so on and so forth, with the introduction of protected areas, to make so that we can then see what are the societal impacts of different choices when it comes to the use of different production practices. Now, with this, having provided an overview of the bottom-up analysis, I want to provide some insights onto the more global analysis, so regional analysis that was carried out with the computable general equilibrium model. Now, this is specifically developed for us to understand the trade dynamics that emerge at the regional level, where there are policies that reach beyond national level policies, for instance, the EU Carbon Border Adjustment Measure, and what are the impacts that will emerge for different countries, especially between EU and Africa, and for what types of crops and commodities. And so what we have looked at is to use this global CG, then with disaggregation of regions within Africa, depending on the type of production that takes place in these areas and the climatic zones, and how they change in these different areas. And so we were able to provide information on scenarios related to carbon pricing, the use of clean energy technologies, for instance, to align with the emission reduction goals of the European Union, how this can be transferred on to African trade partners, the introduction of a unilateral carbon border adjustment measure, or the introduction of climate clubs that will make so that there is more of an alignment towards the reduction of emissions and improve sustainability in agricultural production. Now, these different policy levers or scenario drivers have been combined in different ways under different scenarios. We have, for instance, a business as usual scenario, no specific change to policies and development trajectories. We have a unilateral carbon border adjustment being adopted by the European Union, and no reaction, no sort of a change in policy directives from the rest of the world. And then as we move over to the right side, we see here that we have more of a joint approach, shared approach to emission reduction, with introduction of climate clubs for Africa, and then also more of a global approach to reducing emissions. And so what we see as main findings are the following. If we have a unilateral carbon price introduced by the EU, then we could see that the EU may suffer from a GDP point of view, from an economic point of view. And that is because production will shift over to other countries. Now, this also leads to a carbon leakage effect, which is actually quite important. It may be up to 60% of the emissions that would be, or the change in emissions that would be considered within the EU and at the global level. Now, the introduction of the carbon border adjustment does not seem to actually reduce considerably the carbon leakage. What is coming up as a more effective option is the introduction of the climate clubs. So introduction of shared commitments that emerge from the national level, so from countries within Africa and Asia and so on, to make so that there is an improvement in land productivity towards sustainability. There is an improvement in the use of energy in a more efficient way, the transition to low carbon energy and so on and so forth. The advantage in this case is both a reduction in emissions, and so reduced leakage, but also an increase in productivity. So we could say that the emission reduction is a co-benefit of the adoption of new technologies or the adoption of existing technologies as well that are just more efficient and more productive. And so this is where in a way, the co-benefit can be realized to make so that at the same time, there is a limited reduction in GDP for the European Union, a limited carbon leakage, much reduced, as you can see in this case, with the blue line, dark blue line at the bottom, showing that collaboration scenario, with the leakage being at 20% at first and growing to 40% instead of reaching up to 60%, and where the impacts on GDP overall, considering the negatives for the European Union and the positives for Africa, for instance, will end up being net positive. And so in this case, you see, again, a global collaboration scenario represented by the yellow line, with global GDP increasing, and in the other cases, the impacts for GDP for the European Union potentially declining in the range of 0.5 to 0.7% if unilateral action is being taken. Now, here is also another representation of the impacts on GDP for African regions. You can see in this case that when productivity is improved in relation to the introduction of the climate club scenarios, there is a stronger increase in GDP. And that is happening across all regions. All in the Central Africa region shows a potential decline up to 2025, but break-even is reached by 2026. And the gains are in the range of 1.5 to 5.5%, overall. Now, the lessons learned, and of course, there is a lot more detail in the reports that we have developed for the project on each of the case studies and on the CG model. There is a 250-page report available and shorter sections being published and released at the same time for each of the case studies and modeling approaches used. But the lessons learned in general is that the sustainability of agricultural trade is deeply connected to the sustainability of domestic production. So there is that ripple effect that goes from policy to local dynamics to landscape-related dynamics, including all the social and environmental dimensions and not only the economic ones. These are all intertwined. Now, what we find, and this is not new, is that the economic valuation of externalities, including social and environmental externalities, is crucial to drive sustainability. We really see the economic performance of these investments changing considerably when externalities are being included and or their economic valuation is included in cost-benefit analysis. And then the adoption of sustainable practices, as indicated earlier, is not only about environmental stewardship, it's really about increasing productivity. So the impact on emissions, the impact on improved ecosystem integrity and condition can be seen as a co-benefit in a way, if we want to take more of an economic perspective. But if we take an environmental perspective, the co-benefit is the improved economic performance. So overall, we see that the use of an integrated modeling approach highlights the need for a comprehensive strategy, right? And as Martin mentioned earlier for trade forestry, improved coherence of the policy approaches or the policy instruments that are being used. Because there is a high degree of interconnection between the dynamics of trade that we see between the EU and Africa, for instance, and the dynamics of production that we see at the national level. And so overall, taking a more integrated modeling approach allows us to have a better representation of reality and therefore to provide better insights for policy development. So with this, I end my presentation, and Mari, over to you.